The categories we like to talk about are acids, bases, and salts. The acids contribute free protons, those are our H+ hydrogen ions. And the bases accept those protons and contribute hydroxyl ions, so those are our OH negative. And salts contribute neither. The other thing we like to talk about related to ionic solutions is a neutral solution is the case where the number of hydrogen ions and hydroxyl ions are equal. So it kind of balances, and thus the word neutral. When we talk about our hydrogen ion concentration, this is how we like to write it. And hydroxyl ion concentration, this is how we like to write it. Now these concentrations are based on molarity. And molarity is a numerical concentration that gives the number of moles of solute in 1 liter of solution. So these guys are going to be labeled moles per liter. If we know the hydrogen concentration, we want to find the hydroxyl ion concentration. So here's our handy-dandy formula that we use for this. And that is that the concentration of hydrogen ions times the concentration of hydroxyl ions equals 1 times 10 to the negative 14th. So here we're using that scientific notation we learned. Okay, let's look at this example. An aqueous solution has a hydrogen concentration, that's my H+, of 0.0035 moles per liter. Find the concentration of hydroxyl ions in this solution. As we see that this formula uses scientific notation, this number we're given is not in scientific notation. So let's convert it. My hydrogen ion concentration started out as 0.00035 moles per liter. To get it into that scientific notation, I'm only allowed 1 digit to the left of the decimal place. So this number has to be between 1 and less than 10. So I'm going to have to move my decimal 1, 2, 3, 4 places to the right to get 3.5, and I'll multiply by 10 to the, well, I moved 4 places. Now we have to decide whether that exponent is positive or negative. Well, look at the number we have here. That's 3.5. The number that we started with was much smaller. So to make this smaller, I put a negative. My hydrogen ion concentration is 3.5 times 10 to the negative 4th moles per liter. Much easier to work with. So let's sneak back up to that formula we need to use. And we're going to be looking for this guy, the hydroxyl ion concentration. So I'm going to substitute this value in for the hydrogen ion concentration. So here's what we have. 3.5 times 10 to the negative 4th, and I'm going to multiply that times my hydroxyl ion concentration. And I know that that product gives me 1 times 10 to the negative 14th. Well, look at this as if this guy was a variable, say x. I know I'm solving for that, so I have to get rid of this on that side. How's it attached? Multiply. So I'm going to divide both sides by 3.5 times 10 to the negative 4th. So this is where these two cancel. I'm going to end up with my hydroxyl ion concentration, and I get 2.857 times 10 to the negative 11th, and let's round it to the nearest tenth. So my hydroxyl ion concentration is going to be I check the value behind it. If it's 5 or greater, I go up. 2.9 times 10 to the negative 11th, don't forget to label, moles per liter. That is my answer.